So today, I'd like to welcome Jeanette Chute. Jeanette is president-elect of the Chicago chapter ASA, taking over as president next year. Jeanette is VP of Data Science at Redwood Logistics and has served in a number of organizations and across industry verticals, so brings to her organization, to this talk, a great deal of experience, which we look forward to hearing about. I'm happy to say that this topic today, democratizing data science, is one that I've been looking at for a while. Many people who I work with are quite interested in, and clients are interested in. So obviously you all are. So a very hot topic. And I was happy that when I floated this topic possibility that we immediately had an expert speaker on hand in Jeanette. So with that, I'll turn this over to Jeanette. Jeanette, I'll defer to you as to how and when you want to take questions.
Sure.
So let us know, but we'll turn it over to you. And thanks for talking to us about democratizing data science.
Absolutely. Can everybody see my screen at this point?
Yes.
Okay, great. So I'm going to start out basically just going through a little bit about the company. I'll spend just a few minutes on that. And so I'm relatively new to Redwood Logistics. I haven't been there even 3 months now. And so when I joined, the role is new. So the VP of Data Science is a new role. So obviously there's a lot of things, a lot of opportunities that we have ahead of us. And so just a little bit of background on the company. We have 3 major areas of expertise: digital freight brokerage, flexible freight management, and then our Redwood Platform Services, which is a logistics platform as a service. And as part of that, we have already implemented some data science around shipper and carrier matching algorithm and pricing algorithms. Let's see, there we go. So what do we do best? We're building out SaaS technology, as I just mentioned. We have capacity planning and procurement, shipment planning, shipment management, settlement, freight audit and payment, and reporting. And then some of our strategic partners are listed on this slide. It's probably interesting to note that our LPaaS, our logistics platform as a service, is one of the TMS integrators, so transportation management system integrators. And so the utility of that is it brings together a lot of disparate data sources for logistics, people within the logistics industry. And so it gives us an opportunity to bring to our customers visibility as well as the data science and analytics. So my focus for today is specifically on data science democratization. And the concept of data science democratization can be quite broad. And so what I'm focusing on is the ability to empower what we call expert and citizen data scientists and data engineers. I realize the term citizen data scientist, some people love the term, some people hate the term, but for the purpose of this presentation, I will use that terminology, and I will explain later in the presentation what that means. And by the way, folks, please feel free to chime in at any point in time and ask questions. I'll also, there should be enough of time left over at the end for questions as well. But if you have a burning question, please feel free to interrupt me. While I'm presenting, I can't see you. So if you raise your hand or anything like that, I won't know because I'm in presentation mode. So you will have to interrupt me. All right, so on that note, the 3 major areas of data science democratization, from my perspective, is developing a community of practice, facilitating data science within the organization, and data science governance. Now, I will dive into each one of these a little bit further, but just before we get into some specific examples, I'd like to give you a little bit of an overview of each one. So when we talk about developing a community of practice, we're really talking about providing resources and training for the data science community. And that's pretty much, that could be everybody in the organization, leadership, the executive C-suite, all the way down to people who are literally managing the brokerage on the business side. Creating an organizational knowledge center, providing guidance and oversight for citizen and junior data scientists. So that's the developing a community of practice or a culture around evangelizing data science. Facilitating the data science is obviously more on the implementation side. And that is really collaborating with tech to design and build a modern data platform, for example, providing a POV on data and tool selections, and then upskilling your employee base to create citizen data scientists. And again, I'll talk more about what that looks like and what that means in a few minutes. Data science governance involves things like external evaluations and adoption of best practices, version control around data drift, model drift, as well as code base. And then the integrity of the data and the security of the data. How are we integrating our data? How are we securing our data? How are we using and feature engineering? All of those types of things. So community of practice. The community of practice, one of the ways that we're leveraging that, or I should say creating a community of practice, is by using Azure DevOps. And Azure is just one tool, one platform. That's what we use, so that's what I'm focusing on, but it by no means is the only way to be able to implement data science democratization. Right now, we're using Azure DevOps as a repository, which allows us to put people's projects so that they're searchable, allows us to have documentation, allows us to create proprietary modules, training materials, shareable Jupyter notebooks. And we have most recently implemented Azure ML, which I'll talk about later, but all of this stuff can be utilized within a common platform. And so when we onboard new data scientists or we're trying to upskill, having a thing like Azure DevOps or something similar, right, allows us to be able to maintain training standards and documentation. It also helps to reduce redundancies and allow for reproducibility. So everybody's kind of using a single source of truth, and everybody's able to cross-leverage each other's work. We would also have things like templates and protocols. So what is the best way, for example, to do a proof of concept? Well, you have to start with a business problem, and then you go into a set of hypotheses that you want to test, and so forth and so on. So it's basically providing those best practices, providing those tools and templates to folks so that everybody is able to follow the same processes and standards. Another great advantage of the community of practice is having a data science upskilling challenge. And I actually did this at my prior company, Javi, with the help of my team. Basically, what you can do is you can take different Microsoft learning modules. And we had people at the vice president level all the way down to the data scientist, practitioner level, working on different levels and different tracks. So we had some folks who were very technical, so like the data scientists and data engineers, and then we had people learning about how to use AI and the value of AI to the business, and kind of like a leaderboard platform that we were using, and people could compete to see who did the most training. And we had a lot of fun doing it, actually. And one of the things that came out of that over at Javi was an actual app that somebody created because they learned how to use Power Apps through the training. So there are real world applications. It's not theoretical. It's not, ivory tower. It's being able to learn and to train folks so that they can create value to the business. And we are about to start launching some of these upskilling opportunities at Redwood, which I'll get into in a few minutes. We also, like I mentioned, have content for onboarding. We would like to have standardized assessments and interview protocols for vetting candidates and assessing employee capabilities and interests. And when I say that, I'm not saying that in the sense of being draconian or trying to understand what people's weaknesses are so we can ding them. It's quite the opposite. It's identifying opportunity. So if people have certain capabilities and they have certain interests, but they don't, there's some gaps between where they're at today and where they want to go, we can zone in on those gaps and we can find the right opportunities for them from a professional development standpoint to get them where they want to be in 3 months, 6 months, or a year. And then obviously there's supervision and consultation from experienced data scientists that are part of the community of practice. Sometimes you can implement that doing something as simple as office hours. And other times it's having, and I would recommend having some of the experts on some of the different calls or meetings that you have when you're doing design sessions of how you want to design a product or a solution. So I'm going to move on now into data science facilitation. Can everybody still hear me okay? Everything good?
Yep. Sounds
Okay,
great.
just checking in because it's very quiet and I can't see anything on my end. So, all right, perfect. All right, so AutoML and pipeline. So AutoML provides a framework and an architecture to support model building and deployment with significantly less effort. There's different ways you can do that. You can do that using Azure, which is what we're doing at Redwood right now. You could do it with Data Robot. That's another type of platform where you can facilitate data science. And we're also looking into that and considering something, a platform like Data Robot as well. But currently we have began to work within the Azure Machine Learning Studio. And that's a perfect example of data science facilitation because it takes us through the whole process of being able to start a POC and test hypotheses, creating a prototype, and then deploying those models and monitoring those models in production. And so when we go from left to right, we see on the left side, defining objectives, problem definition, and success criteria. That's very difficult to automate. You're not really going to be able to automate. As you get further to the right, each of those content areas or each of those parts of the process are more automatable. But in the very beginning, defining the objectives, you have to do with the business. You want the business involved throughout the entire process, but the business is critically important in the very beginning to define the objectives. And that's part of the data science democratization. You want to bring the business into the process. And so using things like Data Robot or Azure Machine Learning Studio, again, you can prototype, you can train models, you can do feature engineering, you can validate those models, you can deploy and you can monitor all within the same platform. And you could do it with an SDK. So a lot of the more expert data scientists who prefer to code and do things a little bit more on their own, they might use the SDK part of the the machine learning platform. But people who are not coders or who do not wish to code, but have a lot of business knowledge and expertise, they're going to want to do something more user-friendly like a drag and drop. And so it allows people to do AutoML and do drag and drop and test hypotheses and train some fairly simple models without writing any code whatsoever. So it gets people moving faster and more productive. And then everything's reproducible. So we don't have redundancies. This is an example of how you would evaluate the investment in something like a Data Robot. Now Azure, for the Azure platform, when we use Machine Learning Studio in Azure, there's no subscription fee to have it. You basically pay as you go. So you're paying for your storage and your compute, right? So there's no incremental cost other than however many VMs you're using or how much compute you're using in storage. However, when you get to things like Data Robot, there are subscription fees. And so when you decide which type of platform you want to use to help with your data science facilitation efforts, you'll definitely want to make sure that you do an ROI assessment or some sort of a economic assessment as to, is it worth it? And so you'd have to basically determine how much is this platform going to increase the capability of your team. So if you think that your team will be 33% more efficient, then you would be able to translate that into how much money you're either saving or you're not spending, basically. And so based on the number of resources that you have. The key questions to ask here when you decide whether or not to adopt one of these platforms is how much ML, machine learning and AI work is there to be done? Now at Redwood, we have a pretty robust data science roadmap through 2022, and we have a backlog beyond that. So there's lots of opportunity. And the next question is, what throughput do we want or need to achieve? How fast do we want to move? So those are two things that you want to consider when you decide whether or not the investment makes sense. So I'll talk a little bit about the citizen data scientist. And I need to caveat a little bit here. The definition on this slide and the kind of the donut chart that corresponds to it is something that I've come up with based on my own research. So I've looked at things like McKinsey research, Gartner. I've also looked at, my business, the places I've worked, and things that I've learned from talking to other people in this space at different webinars, conferences, summits, what have you. And I basically came up with this. So you may or may not 100% agree with how I'm defining this, and that's fine. If there's feedback or questions about this, we certainly can entertain that on this call. But for the most part, this is how I'm defining the citizen data scientist. It's somebody who has significant business expertise. They're a subject matter expert in their domain. So if you're in the logistics industry, they're a logistics expert. If you're in the risk industry, they're a risk expert. If you're in, finance or whatever it may be, they're an expert in that space. That person is usually pretty easily able to specify business requirements, which oftentimes folks who are data scientists or more on the tech side are not necessarily as capable of doing, or it takes a little bit longer sometimes to get to where you need to be in terms of identifying and specifying those requirements. So having someone from the business who gets upskilled into what we're calling a citizen data scientist will add a lot of value because they are bringing all that capability to the team. This person has an interest in more advanced techniques. So they may have had some statistical training, like they may understand like a normal distribution, they may understand confidence levels, they may understand t-tests or basic ANOVA or basic simple linear regression, but they have the interest to learn multivariate analysis and to learn more about machine learning algorithms and AI algorithms. They tend to have low or no coding skills. Now, a lot of times you might see business analysts who come in and they have like SAS skills because, back many years ago, that's what I used for the most part in business was SAS. In academia, I used SPSS, which required basically no coding. And so the coding skills that they have, they either don't have any or the skills that they have are antiquated or not applicable to the current situation. So they may be lacking things like Python, Scala, R code, whatever it is that the team is using. They may have some SQL coding skills, but probably not very complex. And they have here are two really important things that a business subject matter expert will likely bring to the team that is likely a gap on your team, right? On a data science team or a technology team. They have a strong capability to storytell. A lot of data scientists struggle with that because they're more about the visualization as a means to an end. I'm looking at a scatter plot, or I'm looking at a box plot, or I'm looking at a time series to try to help me understand how to feature engineer and to help me to understand which models to select. They're not necessarily relying on visualization to tell a business story or to tell a story to a customer, right? It's not that they don't want to or they don't think it's important. It's just not what they're typically used to using visualizations for. And so they may lack the experience in storytelling. And the last thing that's very important that a business person, a power user from the business will bring to a data science or technology team is they also tend to have pretty good soft skills. And what I mean by that is they're used to and good with working with the customer facing and communication and presentation skills, along with having the ability to understand and empathize with the customer. So as you see, the donut chart on the right just kind of tries to provide a quantitative depiction of that persona.
Jeanette, maybe I can introduce a question here, and I apologize, it may not be well formed. It's coming up in my mind as you're talking here, but here's what I'm thinking and wondering. A lot of organizations have over the last 20, 30 years built up internal consulting, problem-solving organizations in the form of like a Six Sigma type program, right? And so we have a program, and we have people and certifications and so on, and I see a parallel there in that many people who are in Six Sigma type programs have similarly some combination of process skills, that is to how you get through, how you solve problems, analytical and tool skills, and and business knowledge. And what I'm wondering is, I guess, what the relationship might be. I can see a couple of possibilities. One might be that a Six Sigma organization in a company could be a place from which could be a great hunting ground for finding these early citizen data scientists. I can also imagine that there could be in some organizations some a battling business units situation where, like, no, that's our problem, no, that's your problem. So I wonder what your thoughts might be on the relationship between data science, and especially the sort of democratized data science, and and that other kind of sort of quality and continuous improvement, but also very data oriented approach to business that has come up through the through the sort of business process improvement and Six Sigma type world. Thoughts on that?
Yeah, absolutely. I love the point. I love the question. I think it's very relevant. So Six Sigma is a process, a methodology, to some extent, I would say a philosophy, right? Kind of like an agile methodology. So you have different ways of thinking and different processes that people employ to get to a destination, right? Now, Six Sigma, in my opinion, has a lot of the like rudimentary foundational skills of what you need to be a good data scientist, right? It's based off of the scientific method. If you look at the Six Sigma handbook, it's going to have some ANOVA, some linear regression examples. It's going to talk a lot about design of experiments. So it really helps you understand what are the right questions to ask, what are the right ways to look at data to solve a problem. It's methodical as well, right? You mentioned that. So I think that when you take somebody who's got like a black belt in Six Sigma, for example, they're like the mastermind of the project that's being implemented, and they're going to tap into folks like a data scientist to be on their team to help them explore something a little bit further than they might have been able to go on their own. But I do definitely think that the concepts that are covered in Six Sigma are highly relevant to the data science discipline. And I do believe that following a Six Sigma approach makes a lot of sense. So for example, if we're going to do a proof of concept to try to figure out if we can come up with a better, I'm going to make this up as a hypothetical example, a better shipper to carrier matching algorithm, right? We want to pair we want the best combination of a shipper to a carrier to optimize the customer experience as well as, our margins. We need to come up with a proof of concept. We need to come up with a set of hypotheses. How are we going to tackle this problem? And I think the Six Sigma framework provides an excellent framework. Looking at statistical control charts makes a lot of sense in pretty much everything we do that entails the use of data. And then finally, I would say that like to complement that with something like the agile methodology. Now for POCs, I think Scrum is overkill. I kind of like to do a combination of Scrum and Kanban, but I think adopting different methodologies where they're relevant, again, Agile, Six Sigma, those frameworks make a lot of sense.
Thank you.
Yeah. Thank you for the question, for the comment. And then somebody give me kind of like, let me know when I've got about 5 minutes left here. From when you want to stop, because I can't see the time either.
Okay, we'll do. So we'll maybe stop by maybe around 1:45, leave 15 minutes for questions. Does that sound?
Yeah, that's perfect.
Good. Okay, yep. We'll give you a heads up when we're getting close to that.
Perfect. Okay, so data science facilitation, and now I've already alluded to a lot of this, benefits of upskilling. So, when you're able to upskill a business expert, sometimes we call them power users. That's a term that we use oftentimes. they come out at the end with stronger machine learning modeling and validation skills and stronger coding in SQL and Python. Now, we're not trying to make them production coders. Please don't, like, that is not what I'm saying. Personally, I don't want to write production code, right? So there's people who write production code, and there's people who write code to do things like, you know, prototyping and POCs. So that's kind of what I'm talking about. If you have a very complex SQL query, go tap your data engineer, right? So it's enough for them to be able to explore the data, do exploratory data analysis, and do some quick hypothesis tests. And, you know, why this is so important is it eases the burden on the data scientists. One of the biggest complaints that I would get from data scientists, which would cause burnout and dissatisfaction, and at worst, you know, churn, is that they get constantly be tapped to pull data. Can you pull this data? And it's the same thing. They're pulling data for somebody. They don't want to do that. So giving people the capability to self-serve on that is very, very helpful, because it allows us to be more efficient. We can have quicker turnarounds. The business team is not sitting there, you know, the business analysts are not sitting there waiting for the data scientists to get free to pull them their data. And I've seen this happen. 9 o'clock at night on a Friday, I, you know, might get a ping. Hey, I'm trying to pull this data from, you know, whatever it is, Azure, and, you know, I don't have access to the data. Can you give me access? Yeah, sure. I go in there 2 seconds. I'm able to give them access. That's an easy one. Well, sometimes it's there's an error and you can't troubleshoot it. And so, you know, we want to make sure that if that person has a customer request that they get at 8 o'clock, 9 o'clock on a Friday night, that they need to turn around by the next morning or within a few hours, that they're not tapping the data scientists to try to get them the data and the resources, the information that they need. That is so critically important. So we have to set up a platform that avoids those types of pitfalls and facilitates that, or empowers that business analyst. Again, we're going to get more effective storytelling, because they're good at it for the most part in general, and they're experienced in it. And so if you have a good story, you have better decision making that takes place as a result. The employee feels empowered. They can do their own work. They don't have to depend on other people. They have more autonomy, more control. And then, like I said, it could even impact retention. The data scientists are relieved from the support role, and the citizen data scientists feel like they have more skin in the game, and they have more autonomy and control over their environment. There's nothing worse than to be sitting there waiting for somebody to respond to give you what you need when you know the clock is ticking and you have a customer deliverable coming up in an hour. Okay, so I'm going to switch gears now to data science governance. When we think about version control, you know, we're thinking about version control of the code, of models, and of data. It's very important that we're able to check in code and commit code and make sure that the code is it has high integrity. Same thing with the data. As we modify the data and we have different versions of the data, we want to make sure that we can go back to an earlier version and that we understand what changes have been made. Obviously, models, that's very important, because we're looking at comparing models to see which model outperforms the other, holding all other things constant, right? So we want to make sure that we understand which model is which. Reliability and validity of methods and standards for hypothesis testing. And again, that's kind of where the Six Sigma framework can come into play quite nicely, is it really preps and provides a framework for doing reliable and valid methodology. Best practices in data exploration and cleaning. You know, how do we treat outliers or anomalies? What do we do with missing values? And the answer to that question could be different depending on each use case or depending on each data source. So you want to have a single source of truth. You want to have a set of rules and reproducible capability, so that people are not trying to refigure it out every time they need to do an analysis. Now, feature engineering, for those of you who don't know, is really the art and science of creating the variables, where we call them the features that go into the models. Okay, they're usually the predictors of a target variable or a dependent variable, as a lot of people know. Feature engineering is the art of creating new variables from raw data. It's transforming variables. It's all kinds of different ways of creating new variables, or what we call features, to input to the model to see if adding that data improves model performance. And that is it's a challenging part of the process, and it takes a lot of time. And again, it's a combination of an art and a science. So you want to make sure that people are not getting stuck unnecessarily in that phase. Model training, validation, and monitoring. Do people understand how to properly train and validate and monitor models? Are they using the right splits between a training and a test set? Are they validating appropriately? Are they looking at the right metrics? Best practices in data visualization, coding standards, documentation standards, and if appropriate or applicable, agile methodology. Again, I like to govern my POCs with kind of a hybrid of Scrum and Kanban. So we do 2-week sprints, but we don't point. We don't do user story pointing, because we're not writing production code on things that are already figured out. Our POCs are experimental in nature. And so it's a little bit more of like, I don't know if you're familiar with the term spikes, research spikes. It's kind of more like that, where we don't necessarily know where it's going to take us. And so a pure Scrum approach is probably a little bit too strict, a little bit overkill. So I like to have the sprint reviews with the business and follow that. But we don't use user stories. We don't point. We're not looking at team velocity and trying to bring down, or increase the team velocity. We're not doing those types of things, at least not for the data science experiments or POCs. In other parts of the business, we certainly are. So here's kind of like the data science democratization plan that we're working with. And this could change, but as of now, these are the things that the team and I are thinking of doing at Redwood, and we've already implemented some of this. So we've identified, actually we have a few more than 2 to 3. We have more like 4 or 5 business SMEs that are very interested in getting upskilled. We were able to find a partner at North Carolina State University who is offering an AI program. It's for employees who are currently working, on the job and want to evolve or transition into a more data science role. And so there's 4 courses to the program, and they're assigned a mentor at the company. And we have a number of people who are very interested in participating in their next cohort that starts in January. And the beautiful part of it is we're able to do this. We're given some opportunity to do this for free, actually. So that's wonderful. So that's one of the things that we're going to be doing. I mentioned the Microsoft training opportunity. We might do that at a later date. We've already set up our Azure ML workspace. People are using it actively now. We're in our first POC since I've joined, and things are going fairly well. We have the data science team working with the business SMEs to leverage the no-code, low-code Azure Studio. Now, to be perfectly transparent, we haven't gotten to the point yet where we have the subject matter experts in Azure actually using the UI or the GUI, drag and drop. Right now, we brought the business into our POCs as subject matter experts. And as we start to mature, we will gradually bring some of these folks into the AutoML platform. As we do that, we would provide guidance, supervision, and consultation. We don't want people to just be running models and they really, they don't necessarily truly understand all of the idiosyncrasies of the model. And we want to make sure that there's some governance or some supervision that's in place, but we certainly don't need to hold their hand or run the models for them. We can be the consultants that they go to and say, hey, I have this hypothesis. This is how I want to approach it. Does this sound reasonable? We provide feedback, and then we look at the result, the output and the results. We're in the process of creating wikis in our Azure DevOps to create the resources so we can publish a lot of the things that I spoke about earlier. We've definitely worked closely with the business to identify and prioritize our data science roadmap. So like I mentioned, we have a data science roadmap going out to 2022. We've worked with some of the business folks to score and prioritize a bunch of use cases based on, it's a strategic fit, economic value, feasibility to do the work, and those things that kind of came in we're using like kind of like a magic quadrant to assess. And then those things that fall within the upper right of that quadrant, we have selected and prioritized based on any dependencies. And the point is, we have the business providing input into that process. They're a part of the data science roadmap. We have, like I said, hypothesis tests, quick hypothesis tests that we're doing that are allowing us to kind of iterate more quickly. We're including data engineering in our meetings, especially when conducting POC design sessions. So if I can say anything, make sure that your data scientists and your data engineers are lockstep. You guys are talking all the time. You guys are, the data engineers are in your design sessions. They know what you're doing. They know what data you're using. They know which platform you're using, and they're part of the decision-making. That will allow for data science democratization and facilitation within your organization. Another idea would be to conduct 1 to 2 hackathons per year. Thinking about incorporating that into our data science democratization roadmap. I already mentioned providing mentorship and consultation. And then another thing that's a good practice is to have some, third party, an external group or person or vendor come in and just kind of evaluate what you're doing. Get somebody else's perspective, get an outside in perspective to make sure that the things that you don't know don't continue to be things you don't know. That at least, even if you don't know how to solve it, at least you know what you don't know, right? So that's really important, is to get that outside in view. And then I think that should sum it up. We are hiring. So if you're interested, now I don't have any open data scientist positions currently, but there are tech roles that are that we're recruiting for right now, and there's other roles as well. So feel free to look at the website, and if something looks interesting to you, feel free to reach out. And great, thank you. So I guess now's a perfect time for questions.
Yeah, I have a couple here, but yeah, I'd love to invite members of the audience to come off mute and insert a question if you like, or pose a question.
Or a challenge. If somebody wants to challenge something I've said, feel free to do that as well.
I've got one of each.
Hi, Jeanette. Thank you so much for presenting on this very important topic. I agree with you entirely on the methodology for democratizing data science. My question is, I guess, goes right from one of the last points you meant, was keeping your data scientists and your data engineers in lockstep. And if I may laser focus on just that one point. So while we've talked a lot about the data science aspect of bridging with the business stakeholders to develop the proof of concepts and so on, can you speak to the other side of sort of the continuum where you are productionalizing those models, those solutions you have now created out of the successful proof of concept projects? You've created capabilities, AI capabilities, sophisticated new business capabilities that are built on data science, data-driven methods, and so on. My question is, have you given thought to how that would work? What are some of the challenges you faced on taking the initial data science democratized with the business stakeholders and everybody using it to let's put it into production. Let's build something out of it that's tangible and generates value.
Excellent. Yes. Thank you for the question. That is oftentimes the trickiest part, right? So basically, one of the areas that I've noticed has been a weakness, and I've seen this not just in the organizations I've worked in, but I've also heard this as a pain point from other folks in this space. DevOps, right? There's a gap. We don't have sufficient DevOps support. And so data engineers fall within the DevOps spectrum, right? So I think of the data engineers as kind of, in the way I simplify it, is they're the bookends of the process. They help us at the front, or upstream with the data ingestion ETL, and then they help us with the deployment at the back end, at the downstream. And so there's a DevOps component to that productionalization that is often lacking in many organizations. And I think that's where the pitfall happens, is because the support's not there, right? We can't have the data scientists be monitoring models in production. And once the models are deployed, they need to be monitored, and they need to be monitored through some sort of DevOps process. And so when we design the POCs, we do the best that we can to make sure that we've proven out, number one, that the models can scale. If the models can't scale in a prototype, then we don't propose, right? We say, okay, this doesn't work. So we run these models at scale as part of the prototyping phase. So that's the first thing. We make sure it can scale. The second thing is its integration, like you said, right? If we're deploying it, how does it integrate with the actual products that we have? And so those conversations need to happen early, like before we start. They need to happen at the design session, right? So ideally, you'd have a DevOps person and a data engineer in the very beginning planning stages of the POC and the design session to say, here's the architecture of the solution, right? And then when you get to the end of the POC, I've actually baked in documentation time, which is specifically geared towards what it sounds like, writing documentation so that we understand what are the models, what are the components of the models, but it's also the handoff from the data science team to DevOps. Here's the way that we're handing it off so that it'll productionalize. But it should, ideally, though, that architectural discussion would have happened early in the very beginning during the design phase. Does that make sense?
You couldn't see me, but I was nodding my head in agreement.
Okay.
Exactly. Yep. Absolutely agree. The one other practical challenge that I have seen was also the availability of the data. So that's where the data engineers have to clean up the data, make that available, make it analytic ready. The business stakeholders may understand their data, but they also need to work again, also in lockstep with the data engineers to get the data in a form that not only can be, the data scientists can begin to use for the proof of concepts, but when there is model drift, as you said, once you can prove something in the POC, but then over time, once deployed, the models do tend to, there's data drift, there's model drift, and so on. All of that needs to be built into that operational process, the ML ops.
Correct. Absolutely agree with you. And the whole thing about the data, I mean, that's an interesting one too, because sometimes people they'll find relationships between variables and they'll be excited about it. But unfortunately, that data can't be used in a predictive model because we don't know what it's going to be in the future, right? We use weather to explain anomalies or outliers in the data in a time series model, but we don't know what the weather is going to be a month out or 2 months out or 3 months out, right? So the best we can use that data for is to clean the series so we don't have noise going into the models, but it can't be a predictor in the model. So it's making sure that we understand the limitations of the data too, right? So what data do we have? How clean is it? What is the utility of the data? How far can you take it? What are the limitations? And another thing around that is sometimes, there isn't sufficient data. I'll give you a perfect example. We're looking at auto booking. Can we increase the take rate of our auto booking? So if somebody gets an automated offer through our booking tool, how do we increase the odds or the percentages of them accepting it? And when we're trying to do the data science around it, one of the limitations is we don't necessarily have really good historical refusal or rejection. We know if they accepted it, but we don't know if they literally rejected it or if they just never saw the offer or what. So we don't necessarily have a pure two sides of the coin on that one, right? We just kind of have one side of the coin on that. So knowing those challenges and then going out to try to get that data, like I'm working with an external vendor right now to try to close that gap with the data. So it's knowing that these things are gaps and limitations. And I think, the data engineer is not necessarily going to know that. That's probably going to come from the business, but you're right. The data engineer is going to be so important when it comes to trying to, once we find that data, we're able to extract that data to get it into a manageable format and ingested and integrated with the rest of the data. And another thing too that I'm reading a lot about, you're seeing it probably, I'm sure you've seen it, is data scientists needing to become more like data engineers. I don't know if that's the right direction for us to go, but I'm reading more and more about, the expectation of data scientists having data engineering skills is growing. I don't know if we're going to get to a point where that comes to like, with the terminologies, we'll get to a point where it stops, right? Or if that's a trend that's going to keep going and the expectation is just going to keep growing and growing, and the data scientist is really just going to turn into a data engineer. I think those are other things that we have to think about futuristically.
Thank you for saying that. I have a very specific perspective on that coming from my experience, but I have to caveat that it is very specific perspective, and it is where I didn't just stop at where you said, well, that's what a lot of people are talking about. I think that's already played itself out, and I'll kind of stop there because this could take us into a whole different direction. My perspective really is, I think data science, as was presented about 10 years ago by McKinsey as the sexiest job of the 21st century, I think it's run its hype cycle. That's over and done with. And I personally do believe that data scientists per se don't really add considerable much value. And because I've had to do this, you hire the PhDs and so on, and you put them with clients and they don't quite work out. They don't make money, the return on investment back. But what you need more practically are those very strong technology folks, usually coming out of IT, who have the statistical background. That pie chart that you gave showed of all the different types of experience, being the storyteller, some statistics background, and so on. The technology folks that have all of that and are able to engage very closely with the business, but at the same time, they're not afraid to write the complex SQL scripts and the Python scripts for the data pre-processing and extraction, and then be able to work with the different tools from Azure and AWS and GCP for working with all different types of data, and then assisting on the development of data labeling, and still also have that strong statistical rigor to be able to distinguish between correlation and causation.
Yeah, that's
be able to get into the interpretability. So they can, even if they may not know it themselves, they can have a meaningful conversation with the business stakeholders and say, let's work through the Shapley output for this predictive model and all of that, and then incorporate that into the model drift. So you need somebody, the perfect unicorn is somebody who is a software engineer with a statistical background, probably also has an MBA, so they can, and is able to think big picture, is able to speak fluidly with the CEO or CXO, chief anything in the company, as well as the offshore software engineers, to be able to do all of that and still move the needle forward during a certain period of time. Is that a data scientist per se? My experience was that the data scientist didn't fit that role.
Yeah, you provide an interesting perspective because you're basically going the opposite direction that I presented. I'm going, bringing the business more to the tech. You're going the opposite direction. Yeah. And I think both are valid directions to go. And depending on who you talk to, some people say, I find it a lot easier to teach the technology people about the business than I find to teach the business about tech. But there are business users who have the aptitude and the interest. And that's what I'm really focusing on when I talk about citizen data scientists. But it's beyond the citizen data scientists. Because so the donut chart is really about the citizen data scientists. But to your point, you're talking about a unicorn. In reality, there really aren't too many unicorns. So like, we want to be able to get a team of people that hit all of those things. And we want to connect the people in the team so they can hand the baton, right? So you got the super, super techie person over here, and then you got the super, super soft skills, communicator over here, data or storyteller, whatever. And then they're just handing the baton down the line, right? So you're going to have a team that's going to have strengths, a different set of strengths along the way. Ideally, you're going to need some overlap between this person and the next, right? To be able to effectively pass that baton. They have to actually touch, right? To get that baton down the different, runners in the race. But if that, and that's an art too, is to design a team like that.
Yeah, it's a very apt analogy. That is exactly what you have to keep in mind when forming a team. And it's a team sport. All of this is a team sport.
Yep.
Thank you. Great question. We probably have time. We have about 6 minutes. We probably have time for one more question with, actual time to answer. So I don't know if there's one more in the audience, bring it forward.
So we do have somebody that has a comment. So this is about using about recommending AWS SageMaker pipelines versus Azure. Yeah, I mean, I think that's perfectly valid. I'm used to Azure. I'm comfortable with it, but I'm not a spokesperson or a salesperson for Azure. It's just what we're using, and I know there are other platforms, and they have their different strengths and weaknesses. The reason why I went with Azure versus SageMaker is because based on the research that I did, it seemed as if Azure was more conducive to the citizen data scientists, but also offered like the SDK capabilities, whereas SageMaker seemed to be more, or AWS seems to be more geared towards your hardcore data scientists and not as flexible in that way.
I think you're right on that. If I may add to it, Azure Machine Learning Studio is amazing, drag and drop. When I present that to C-level executives and say, give me 30 minutes, I'm going to turn you into a data scientist. And using Azure Machine Learning Studio, believe me, in about 35 minutes or so after I'm done, you can't take their hands off their mouse because they're able to spin off a model with an API and they can call from Microsoft Excel and they're just loving it, right? But I would extend that and show now how you can build Azure Machine Learning with Power BI, because Power BI, contrasts to a more expensive Tableau, helps you do some very sophisticated visualizations. All of this, all integrated together, is great for being able to present the capabilities of machine learning, statistical learning, and artificial intelligence with a large pool of data that you can extract out of a data lake or so on. But when you're productionalizing, like you're building the next Uber, or you're evolving a traditional old business to become the next Uber or Airbnb, and you want that enterprise technology capability in your backend, that's when my personal 2 cents, that was the comment, was SageMaker and everything that AWS connects into works a lot better. And if anything, rather than my opinion, all I can say is if you look at the size, the marketplace sort of ownership of AWS versus Azure, AWS has 3 or 4 times the size of Azure deployments and Azure utilization, even though everybody has Microsoft. Every corporation in the world has Microsoft. AWS just has more adoption.
Yeah, that's a fair point.
Jeanette, let me wrap up. I'll ask you one question. It's there's a limited amount of time left, which shows a sort of philosophical question. The limited amount of time will help you because you can just say, "I'm done with the question, I'm done answering now." So here's the question. So you talked about democratizing data science effectively within an organization, right? Which is great. Another aspect of that, in my mind, is making data science and related tools available to more organizations. So for example, for organizations that are in the smaller organizations, let's say, 1 or 200 million up to a little bit below $1 billion, and maybe they're not quite you're in a very data intensive industry. there are others that aren't. And so, there is a fair swath of the economy that, at least right at this point in time, with between talent shortages in data science and their own industry maturity and other things, there's probably some latent opportunity, but that by definition hasn't been really realized yet, or even maybe started to be mined yet. And I just wonder if you have any thoughts about how data science might be, or maybe it will never be democratized truly in, if you will, the laggard organizations. They might be smaller, they might not have the scale for a data science group, et cetera. So any thoughts you might have?
Yeah, so I'm not sure size is a huge contributor, because if you think startups are small and they are some of the most progressive in this space. But I get your point about maybe smaller, mid-sized laggards, right? I think change management is a huge thing. And if you don't have the right leadership in place and they're not willing to do the change management, I don't care what you try to do, it's not going to work. So, I think really at the end of the day, you have to have leaders that buy into it, that hire the right people, are willing to invest, and are ready to go through a change management cycle. I'm not sure if that answered your question, but to me, that's like the first place. I wouldn't even try to implement data science in an organization if the leadership wasn't committed to investing in it and willing to go through the change management.
So a parallel to first you have to recognize you have a problem, or in this case, an opportunity, and then commit to it. So great. Well, thank you very much. We've hit the end of our hour, and I think it looks like folks are starting to leave or need to leave. So we appreciate everyone's time, including yourself, Jeanette. Thank you very much. We will be announcing, further luncheons for the group here every month for the next 8 or 9 months, and so I hope to see you again at other luncheons and events. And meanwhile, thank you all very much for attending, and have a good afternoon.
Thank you, and I'll send the video over to you.
Very good. Thank you.
Thank you. Bye.